evaluate this limit, we got x squared times e raised to 3x. If we take x equals negative infinity, here we got negative infinity squared times e raised to 3 times negative infinity. Negative square means positive. Very big times very big means still big, times 3 times negative infinity means number times very big is very big, so negative infinity, and infinity times e raised to negative, okay, that is 0 in fact, or we can write like 1 over e raised to infinity. Negative means put on the fraction positive. Infinity times e raised to infinity means very big. 1 divided by very big means very small, 0. So we got infinity times 0. Unfortunately, this is not 0. It can be anything. Okay, we know that 0 times a number is always 0. But infinity is not a number. Okay, infinity is not a number. It's just a notation for something being really big. And these are, we are talking about in terms of limit anyways. So infinity times 0, so we got indeterminate term. I mean, that's indeterminate because we don't know the definite value of this. So if we are able to convert this product, because we have product, into a fraction, then we might be able to use L'Hopital's rule. So let's try to convert this into a fraction and see. I mean, that's the only way to that's the only way to evaluate this limit. So limit x going to negative infinity. Okay, here is e raised to 3x. We can put 1 over e raised to negative 3x. That's one way. Or x is squared, we can make 1 over x minus 2 as well, same thing. Maybe let's do exponential. I want to keep x squared on the top and e raised to 3x when we put on the bottom, that's negative 3x. Now if we plug in negative infinity now, negative infinity square is positive infinity on the top, and e raised to negative of x going to negative infinity means positive infinity. E raised to very big means still big, so infinity. We have infinity over infinity, and we know that whenever the limit goes to 0 over 0 or infinity over infinity, then we can apply L'Hopital's rule. Okay, so to evaluate this limit, we apply L'Hopital's rule. I'm indicating that, writing LH. Limit x going to negative infinity. By L'Hopital's rule, what we do, we find derivative of top on the top, derivative of bottom on the bottom. That is 2x e raised to something. Okay, that's, what is that? When we have e raised to, let's say, a function of x, u, its derivative is itself times, from the chain rule, u prime. So e raised to negative 3x is like u. So derivative of this is itself times derivative of negative 3x, which is negative 3. Okay, that's from this chain rule. Okay, if we plug in negative infinity, it's going to be 2 times negative infinity, still negative infinity on the top. On the bottom, we still have that. That was giving us infinity, and minus 3 means negative infinity. And we know that whenever we have plus minus infinity over plus minus infinity, we need to apply L'Hopital's rule again. Okay, using L'Hopital's rule again, we get that. Now derivative of top is 2. Okay, no longer infinity on the top, so we will be done. The derivative of 2x is 2. On the bottom, let me put negative 3 in the front. Now we have e raised to negative 3x times negative 3. So we don't have to use product rule, okay? Number can be just ignored. And derivative of e raised to negative 3x. Yeah, we did here using this rule. So exactly this. E raised to negative 3x times derivative of negative 3x is negative 3. Okay, now let's plug in x equals negative infinity to finish this problem. So 2 over negative 3 times negative 3, that's positive 9 times e raised to negative 3 times x is now negative infinity, e raised to negative negative positive, 3 times very big is very big, e raised to very big is very big. So pretty much infinity. I mean, generally this does not make sense to write infinity, but we know this in calculus. Pretty much we are writing something really big. Really big times 9 is even bigger, really big on the bottom. And a number raised to really big means that's very small, 0. So we could have written 0 on the bottom. Okay, 9 times infinity is infinity, and the number divided by infinity is 0. So the whole limit is 0, final.